we are going to the same chapter number 8, that is motion. Okay, the physics portion. In a motion, first we have to be discuss about the motion, identify intensities of the motion encountered, that is encountered in our everyday life, analysis motion along a straight line, identify uniform and non-uniform motion, calculate speed and average speed, then after define velocity, then after calculate velocity of a moving object, then after explain scalar quantities as well as vector quantities, then after define acceleration, and then after we have to calculate the acceleration of moving objects in our day-to-day life. So all this we have to be discussed in a motion. So here in a motion there will be in a state of object in which there is change its position. The position is changes. Birds can fly. Here the birds can fly, okay, with respect to surrounding at the time. Similarly here the horse is moving from one place to another places. So here all these are example of this motion, related to the motion. Similarly there is another example. We will take the fan can rotate, it is also circulatory motion. Similarly other example we take the proton, neutrons as a nucleus. So as you know that center is a nucleus and all the electrons revolves around the nucleus. It is also in a motion. So all the electrons revolves around the nucleus. So all these are the example of the motion. Here next, as is the sun is the center and all the planet, that is earth, is revolving around the sun. It is also a motion. That is in whole universe, all the planets revolving around the sun. Similar to the example here, the earth and the moon. The moon is revolving around the earth. This also in a motion. Here we take example, all the birds can fly. It is also in motion. That is here the car. The car is in motion. With respect to the, here we take the rest position as well as motion. Both are the relative example. We take this. Here the one man is inside the car and start the car. So beside that here the car is in motion, while rest it is in, that is a stationary object. But we observe from the car all the trees, planet, that is plants, buildings, all are, we have to observe, it is in motion. So here we can say that the motions are the relative. Here the state of rest and motion bodies are the relatives, and absolute state of rest or the motion do not exist. So here another example here, that is the one man seated in the bus and the men, they are in rest position, while remaining all are in motions. Beside that is building, trees, etc. We observe from that is in bus, they are in motion. Here one example that will be here, that is ball, okay, that is in motion. So here as for example, that is rainy season, summer season, autumn season, winter season, spring seasons, they are also in a motion. Here that is in a seasons day by day, that is in every year the seasons will be changed. So here there are type of motions. We have to observe that here, that is one dimensional, that is linear motion. It is also known as the one-dimensional linear motion. So one-dimensional means that is the object moves along the straight path. So car moves in a straight path. So it is a linear motion. Another example that will be here, that is car from one place to another place. It is in linear motion. That is another, that is two-dimensional. It is known as the horizontal or vertical balls will be moved. That is here. The object moves in two directions. The object moves into two directions here. At the same time, horizontal and the vertical. So it is two-dimensional motions. Now we take the third example here. The plane, flying the plane. So an object moves in three directions at the same time. So aeroplane can fly in the, we observe in the three directions. So three-dimensional example. So objects move in the three directions, that is X, Y and Z direction. So in three directions we have to be observed flying the plane or aeroplane. So these are all the examples related to the types of the motions. Now here distance, we discuss about the distance and the displacement. So from example here, house to school, house to school. So these are the distance. So house to school, let us consider it is a distance here. So for that here, house to school, it measured in a distance, and then after school to playground. Okay, so you just start from house to school, which is the school. Then after school to playground you reach. So these are the distance you can be measured. But shortest distance, it is a displacement. The shortest distance, that is final position and initial position. Initial position start from the home and final position is the playground. So let us consider from house to school, it is a 3 kilometer distance, and from school to playground you cover the distance 4 kilometer. But here total distance you would cover 3 kilometer plus 4 kilometer. So total 7 kilometer. But so the distance, what is the distance? Distance is the actual length of the path covered by moving object. Actual distance you should be covered. 3 kilometer, 4 kilometer. Okay, with respect to the direction of the motion. But displacement is that here final position minus initial position. Initial position your house, which is the school, school to playground. Okay, final position playground. So what is the displacement? Final position minus initial position. It is known as the displacement. It is shortest distance. Displacement is the, you should cover the distance, shortest distance. So here displacement is the shortest distance between the 2 points. Between the 2 points, initial position and final position. Now we take example here, the uniform motions. Now here, that is in initial position, that is here motion, that is a uniform motion. To start the position, that is here, that is a straight linear path. Now in a linear path, that is you should cover, that is yellow car. Now yellow car cover the distance, okay, at the respective time within the 4 seconds. So here within 1 second it cover the distance 50 meter. That is in second minute cover the distance 50 minute, third minute cover the distance 50 meter, and fourth second cover the distance 50 meter. So here equal distance, that is equal distance 50 meter, 50 meter, 50 meter in equal time of minute, that is 1 second, 1 second, 1 second, 1 second. And such type of motion, it is known as the uniform motion. So that is in first second 50 meter, that is second 100, that is third second 150, that is 4 200. So that is 100 minus 50 50, 150 minus 100 50, 200 minus 50, that is 150 50. So equal distance covered in equal time of interval, and such type of motion, it is known as the uniform motions. Here that is another example we should take here, that is non-uniform motions. That is second one. In a non-uniform motions, that is an object travel, that is red car over the equal, that is equal distance in that is unequal time of interval. It is non-uniform motion. So here 50 meter distance, that is 100 meter distance, that is 150 to 3, that is 150 meter, that is 350, that is 350 meter. But time is different here. So that is non-uniform motions. So that will be here. Here should be observe that this car, that is first 50 meter, it cover, that is second, it should be show the second here. So unequal distance, that is time first second, that is first one, it cover the distance 50 meter. That is in within the third second, it cover the distance 100 meter. Within 6 second, it cover the distance 150. And within 10 second, it cover the distance 200 meter. So in non-uniform motion, an object travel unequal distance in equal time of interval, it is known as the non-uniform motions. Now we will speed next one. Now as you observe that one person walk, okay, that is another person they are traveling the bicycle. Speed is a different of the walking distance, cycling distance and the car. The distance will be same, but the speed is the change. So here speed of an object is the rate at which the object covered a given distance. It is known as the speed. Here in day-to-day life here we observe that is a speed equal to nothing but the distance upon the time. Speed is nothing but distance upon time. So some object is the high speed, cover the distance high speed. So and some object that is a lower speed, okay, cycling is lower speed. While here an object cover relatively small distance and longer duration is a lower speed. While another there will be no speed. The car is stationary, it has no speed. Now as you know that distance equal to, that is a speed equal to distance upon time. Distance, that is a system in CGS system, that is centimeter per second. While another that is SI system international system, SI unit, it is measured in meter per second, and general unit we can be kilometer per hour. So these are the speed unit, kilometer per hour. So kilometer per hour, 1 kilometer equal to 1000 meter, 1 hour equal to 3600 second. So we obtain that is 3.6 kilometer per hour. So here these are the conversions of the unit. Now we discuss about the speed here. That is one girl starting the point here, that is one house, and cover the distance 3 kilometer, it is the school, and from house to school cover the distance 3 kilometer. Then after school to playground, so it is the school to playground, the distance is 4 kilometer. So here the total distance there will be 3 kilometer plus 4 kilometer. So total distance covered, that is 7 kilometer. But here that is the average speed here, that is the distance 3 kilometer convert into 3 meter. Okay, that is 3000 meter. Time taken, that is suppose taken the 20 minutes, cover the distance 20 minutes. So convert into second, that is 20 minus 60 seconds, that is 1200 seconds. So distance equal to, that is speed equal to distance upon time. So 3000 divided by, that is 1200. So average speed 2.5 meter per second. So these are the example related. Generally we have to calculate the average speed. So generally the motion of an object is non-uniform, not constant speed. An object that is apply the brakes, the speed is increases, sometimes speed is decreases. So we should require the average speed. So to determine the speed at which the object covers the total distance, we calculate the average speed of all the instantaneous speed. Average speed should be calculated. So here as we, that is in generally when we ride the bicycle or ride the bike or ride the, that is car, the speed is increases, then after decreases, stop. So we should maintain that is average speed. So here speed during the 1 second and speed during the second, that is third second, fourth. So we should be example related to the in our mind, that is the speed is different. Here That is one more example here we should read. That is a car here. Okay. That is in first is that distance, second distance, third distance, fourth distance. We should be calculate the average speed of this car within the time interval t1, t2, t3 and t4. So d1 distance, cover the distance t1, d2 distance, cover the distance time t2. So we should calculate it. Ratio the total distance to the total time, that is distance t1 plus t2 plus t3 plus t4 divided by that time, that is t1 plus t2 plus t3 plus t4 up to end. So distance equal to total distance, that is time, that is the distance upon time, speed average. So here, as we previously discussed about, that is uniform speed here, that is uniform motion to uniform speed here. So this is a uniform speed, okay, uniform speed and non-uniform speed. These are the example here. Here, now we should discuss about the speed with the direction. It is known as the velocity. Speed with the direction is known as the velocity. Now the distance covered, that is from the starting point of the car, red car, that is initial to final, that is it covered the distance t. So this uniform motion. Then after it will be the automatically the speed is decreasing. Okay. So then after the speed is increases, final position. Okay here. So we calculate the displacement of this car, that is final position minus initial position, that is sorted distance. It is known as the displacement, as we previously discussed that. As you know that distance equal to, that is the speed equal to distance upon time, we should be calculate the average speed. Now velocity, the speed of an object moving in a definite direction, it is known as the velocity. Or the rate of change in position of the body, it is known as the velocity. The rate of displacement. Here, as you know that displacement, that is the average velocity, that is displacement upon time. Velocity, that is v bar, average velocity. V bar means the average velocity equal to displacement upon time. And from this formula, we can find out the average velocity. The system, there is CGS unit, that is centimeter per second unit, SI unit, meter per second, and that is kilometer per hour. In general, we can calculate the average velocity also. So here, the change in velocity, that is changing velocity, that is changing speed in a particular direction, direction with particular direction, that is changing velocity. We can find out also that is the average velocity here. So how can we calculate the average velocity? So average velocity is ratio of total displacement to the total time. So here start the position, okay, that is initially start position to final position here. So first position, that is in second position, that is the average velocity we should be calculate with the help of the distance as well as the time. Like u is the initial velocity and v is the final velocity. So initial velocity and final velocity. So average velocity equal to distance upon time, total distance upon total time, and from this formula we can find out the average velocity. Here we can observe there is a clock here. Okay. Now the second clock, it will be rotate. Okay. So initial position, that is at 12, but it will rotate, that is V1 velocity, V2, V3, V4, V5, V6, V7, V8, and it is the point here, the final. Okay. So initial velocity and final velocity both are here, that is same. So average velocity, it will be, we can calculate, that is 0. Okay. So here the original position, it will comes in original position. So displacement is 0. Final position and initial position both are the same. So displacement is 0. Now we discuss about the scalar quantity as well as vector quantity. Here, as we previously discussed about this house, school and playground. That is one girl travel the distance from house to school 3 km. School to playground, she covered the distance 4 km. So average we should be find out the distance, that is 5 km. Okay, displacement is the 5 kilometer, but total distance is 3 kilometer plus, that is 7 kilometer total distance, but displacement is only 5 kilometer as we do. Okay, it covers the distance, that is car, that is initial position and final position, cover the distance, total distance, and this is the displacement. So speed equal distance upon time and velocity equal average velocity equal displacement upon time. So these are the displacement. So distance and speed, they have only magnitude. Okay, distance and the speed, they have only magnitude. So here displacement and the velocity, magnitude as well as direction both. Also displacement and velocity, they have magnitude as well as direction, both have. So scalar quantity, that is a scale that is here as example pencil and scale. Okay, that is 10 centimeter. That is length is 10 centimeter. Now this length, that is cover the distance. Okay, 0 to 50 meter, cover the distance. So here area as well as a physical quantity, that is which are the physical, that is length is a physical quantity. These are the distance, physical quantity. So physical quantity that has only magnitude but no direction. Okay, but no direction, it is known as the scalar quantity. Here, so these are the example, both are given, that is speed is also scalar quantity, area is also a scalar quantity. Now vector quantity, here physical quantity that has both magnitude as well direction mentioned, it is a vector quantity. Okay, so here that is as we know that is a distance, that is the distance, total distance 3 meter, 4 meter, total distance 7 kilometer, displacement is 5 kilometer. So physical quantity therefore both magnitude required, it is a vector quantity. Here one example that is here given, that is from point P to Q and Q to R scale. Okay, that is 4 kilometer and 3 kilometer. These are the displacement, shortage distance. Okay, so here it's starting the point, that is from P to Q point. Okay, car travel the distance 4 kilometer. Then Q point to R point, it cover the distance, certain distance at the 4 kilometer, and shortage distance, that is 5 kilometer, we should be opting. Now next one, we should be observe that here that is rate of change of the velocity, it is known as the acceleration. Rate of change of velocity, it is known as the acceleration. So this car is known, okay, we should be calculating the acceleration. So acceleration is the rate at which the moving object changes its velocity. Okay, it is known as the acceleration. So as your car is moves, okay, on this own path, and with the speed is increases, speed is decreases, speed is increases, speed is decreases. So we should, the rate of change of velocity is known as the acceleration. So here, so these are the example. Acceleration is equal to nothing but the change in velocity per unit time. So change in velocity is final velocity minus initial velocity upon time. Let acceleration denoted by small a, and that is acceleration CGS unit centimeter per second square and SI unit meter per second square. So these are the unit of the, that is the acceleration. Here the we discuss about, that is a coconut tree, and coconut is the falling on the surface of the earth. Okay, so with the great acceleration, the having the gravity, that is g. So speed is increases, decreases. Okay, increases, decreases, we observe, that is acceleration. Now we discuss about the retardation. Now bus starting point. Now driver applies the brakes. Okay, the speed is decreasing. After some time it will be stopped. So it is example of the retarded motion. Okay, by applying the brakes, the speed is decreasing. So it is also a retarded motion. So an object moves such that its final velocity is less than its initial velocity. Okay, both are the different. It is retarded motion. Here, now some point related to the motion. Discuss, that is distance related to the time as well direction. Okay, distance both are, that is direction as well as time. Another derivative, displacement, related to the direction as well as time. Displacement, okay, from one place to another time with the help of the time. Now the speed in respect to the time. Another derivative, direction. Speed in which direction is covered, that is it related to the velocity, and velocity related to the acceleration. So here, now another topic will next in the next video.